For this lecture, we will be trying to convert decimal numbers to hexadecimal number system. So this is from base 10 going to base 16. For example, number 1, we will be trying to convert this one, the number 2020, to the hexadecimal number system. So it is the same method that we did on converting binaries and octals. So you need to successively divide the integer part to the radix, this time 16, get the until the quotient becomes 0, and take note of the remainders and read the remainders backward. And for the fraction part, you should be able to multiply successively the fraction part to 16, get the integers resulting from that multiplication, and then that is the resulting hexadecimal digits. Let's try number 1, 2020. So to convert 2020, we need to divide that successively to the radix of hexadecimal, which is 16. We know that 16 over 20, you can only get 1. So you have 16, then you have 42. Then 16, how many 16 can you get in 42? So I think you can only get 2, not 3, because 3 is 52 almost. So you only get 2, so that you can get 32, and you have 0, 1, and then may 0 pa. So you can get, how many 16 can you get from 100? The answer would be, that is almost 6 or 6 or more. This time, 6 times 16, you get 96. So you have a remainder of 4. Okay, take note of that. Then the quotient will be divided again to the radix 16. So we get, how many 16 can you get from 126? Okay, correct. You have 7 only, because 7 by 16 will give you 112. Okay. And then this is 4. This is 1. Then, so we already completed the division, so our remainder is 14. So take note that in hexadecimal, numbers from 0 to 9 is labeled as 0 to 9, and above 9 is labeled as letters A, B, C. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you go A, B, C, D, E, F. Okay, so if you count all these characters, that should be equivalent to or equal to 16. So your A is equivalent to 10 in decimal, and so on. Okay. Okay, so we know that 14 is letter E. Okay. Then our quotient is still not 0, so we need to divide again that to 16. This time it is not uh, divisible by 16. It will yield to a fractional part, so you have 0, then 0, then you have a remainder 7. Okay, so you read it backward. So the equivalent number of 2020 in hexadecimal is 7, E, 4. Okay, base 16. Okay, so that is your answer. Okay, how about if we have the fraction part? So this is the same for the integer part, that is the same that we successively divide the integer part to the radix. So we start with 75, divide that by 16. So how many 16 can you give, or can you get from 16? How many 16 can you get from 75? So you can only get 4, and then that is because 4 by 16 is only 64. Then what is their difference? you get 11. Okay, so the remainder 11 is written as B. Okay. And then 4 divided by 16, we don't stop because our quotient is still not 0. This time you are getting 0, so you have 0. Then you have a remainder 4. So you read it backwards, your integer part is 4b. How about the fraction part? So you need to multiply that to the radix. Okay, so you'll be getting 0.27 is 4.32. So take note of the whole number. Then the remaining fractional part, just successively multiply it to 16. Okay. Then you'll be getting 5.12. Okay. Then the 0.12 part should be multiplied again by 16. You'll be getting 1.92. And then 0.92. Okay, take note of this. Times 16 is, that is 14.72. So take note of 14. That can be written as letter E. Okay, and then the fraction part remaining, 0.72 times 16 is equals to 11.52, or F. So let's assume it will be continually multiplied. Let's assume that we stop at 5 decimal places. So we got our answer as 451 E F. So you combine what you get in the integer part and the fractional part. So your answer should be 4b point 451 EF base 16. So that is the answer for 75.27 base 10. So that's it for your conversion of decimal to hexadecimal. See you in the next video.